Dear students, let's solve some numericals based on the first law of thermodynamics. So this is the numerical given based on the first law of thermodynamics. In a process, 1000 joules of heat is absorbed by the system and 600 joules of work is done by the system. What is the change in the internal energy of this process? First write down the given data. Q is 1000 joules and the work done by this system is 600 joules. What is the delta U? Draw the diagram for this diagram for the given numerical. This is easy to understand the concept of the first law of thermodynamics. So 1000 joules of heat energy is added to the process, then that will be converted into internal energy as well as work done by the system. From the first law of thermodynamics, we can write down the delta U is equal to Q minus W. Just substitute the given values, we can get the change in internal energy of the system. Here Q is added, that's why Q is plus W is done by the system, that is minus sign. That's why the change in the internal energy of the system is equal to Q minus W. Similarly, let's perform the same mathematical statement of the first law of thermodynamics for one more numericals. A system consisting of some fluid is stirred in a tank. The rate of work done on the system by the stirrer is 5 HP. Similarly, the heat is generated due to the stirring is dissipated to the surroundings. If the heat transfer to the surroundings is 3600 kilojoules per hour, then calculate the change in the internal energy. Similarly, write down the given data. W is given 5 horsepower, that means 1 horsepower is equal to 745.5 joules per second. Okay. Similarly, convert the amount of heat energy transferred from the system to surroundings. 3600 kilojoules per hour. Kilojoule means add 1000 joules. 1 hour will be converted into seconds. 1 hour equal to 60 into 60. 3600 seconds. So we can get the 1000 joule per second. Both are units should be the same. If you look at this diagram, then you can easily understand this concept of this first law of thermodynamics. There is a tank, there is a stirrer, fluid is mixing by the stirrer, and the amount of work done by the stirrer is 5 horsepower, that is equal to 3727 joule per second. The amount of heat transferred from the system to surroundings, that means due to stirring, heat energy will be generated in the fluid, that will be transferred to the surroundings because there is no any insulation of this reactor or tank. That's why 3600 of kilojoules per energy is transferred to the surroundings. So in the previous example, Q is added, W is removed, that's why Q minus W. Here opposite, W is added to the system. What is system here? Tank. This is the tank, this reactor or fluid. Q is lost, that's why then the first law of thermodynamic statement will be the opposite in direction, minus Q plus W. That's why the change in the internal energy of the given system is minus Q plus W, because Q is lost, W is added to the system. By substituting these values, you can get the change in the internal energy 2727 joule per second. So the change in the internal energy of the given system is 2727 joule per seconds, right? So this is a way to solve the numericals related to the first law of thermodynamics by knowing the opposite signs of the work done by the system or work done on the system, amount of heat added on the system or amount of heat lost by the system. By knowing these signs, we can easily solve the numericals related to this first law of thermodynamics. These are the self-assessment questions, zeroth law and the first law of thermodynamics, and a mathematical statement and a theoretical statement of the first law of thermodynamics. These are some reference books are provided. Thank you.